welcome to AP Calculus. We're working on integrals, sometimes called antiderivatives. And it says find f of x, and I give you the first derivative on number 1. And what I want you to see is it is a composite function. It has sine and a polynomial in it. So there's two different rules happening here. First thing I think of is I deal with the trig portion. And I've memorized, and you should have these memorized by now, these derivatives. And the first thing I think of is, oh, I have sine. All right, derivative of cosine. Oops, and I missed the negative. Derivative of cosine is negative sine. And the first thing I do is I don't have negative sine, I have positive sine. So I multiply both sides by a negative. So I right away know that if I have sine as in the first derivative, it derived from negative cosine in the function. And then I can do a quick check at just that term, and it's okay. And then my rule is I add 1 and divide by the new power. So it becomes negative 3/5 x to the 5th. And then our favorite thing, this is a general antiderivative because I have no condition. So it has to be plus c. Every time you take a step, there's a constant. If you take more than one step, you end up with multiple constants that are not the same. So that's really leading us into number 2 today. Number 2 is the second derivative, and I wanted you to find the function. So you take the first step, the antiderivative, or the integral of f prime prime is f prime. I'll add 1, so I get 5/3 x cubed, and then I'll have some constant, which I'll call c. There's the first derivative. No initial conditions, so I'm going to do another step in black. And the integral of f prime is f of x. I add 1. All right, so it's going to be x to the 4th. Guys, 5/3 divided by 4, or 5/3 times the 4th is 5/12. And then this is the tough part. The integral of c is cx. And then I have a different constant here. All right, and I don't care which one you label c and c1, or if you label them c1, c2. Doesn't matter, we just need some notation difference, okay? Again, these are called general antiderivatives in our textbook, or general integrals, because they just have constants, okay? I will tell you straight up, when you get initial conditions, you're going to not have c, you're going to have values. Whoops, sorry about that. So when you see this initial condition right here, you're pretty sure you should be able to drive it to a number, okay? And so I would first do the same thing. I am thinking about these derivatives over here. I see that I have, this time I have negative signs, you guys agree? So if I come back over to my other problem, I can think of it as negative sign this time, right? I ignore the 3. And I know then that f of x is going to be 3 cosine x for the first term. And I double check it by doing the derivative in my head. Boom, it works. Then I add 1 to this x squared. It's x cubed over 3, or 1/3 x cubed. And then I'll write the plus c right now, and that's why I did it green. All right, plus some constant c. All right, now we have to do this. We have to use our initial condition. So when I plug in 0, and I do this problem on purpose, guys, because often what I have students do at this point is they say, oh, the constant's 2. The constant is not 2, guys. I agree that this term goes to 0, the middle term, okay? But the cosine of 0 is 1. I subtract 3 on both sides, and I get negative 1 equals c. So the antiderivative, or the integral of this function, is 3 cosine x plus 1/3 x cubed minus 1 due to the antiderivative. Okay? And then initial condition. Keep practicing. All right? The AP test has quite a few of these in the multiple choice.